let me know when you join the coder pad.
Yeah, sure.
Okay. Okay, cool. Looks like you're in here.
Yeah.
And then what language do you want?
I'll go with C++.
C++, okay. Yeah. Okay, cool. Yeah, I'm a little bit less familiar with C++, but I mean, the stuff's all the same. It's pretty readable. Okay,
Like which
so
language you are comfortable with?
what was that?
Like which language you are comfortable with?
I mean, I know C++, that's like Python or something, but for like leak
Okay.
code, I can still read it. Like, right? It's not complicated. It's still the same.
Okay.
Like, you're not using complicated C++. It's like vectors and all that stuff. Okay,
Right.
so let's just say, okay, so 7:05. So we're gonna go until 7:45, and then we'll do feedback. So like 40 minutes. Okay, so I'm gonna give you problem here. It's like a pretty common one, and then you can ask all the questions you want. So I'm gonna paste it up here. Okay.
Okay. I'll just go through the problem.
Mhm. And if
We are
you've done
given.
this one, let me know and I can find something else.
Sure. Okay. So you are given a zero indexed array of positive integers w, where wi describes the weight of the ith index. You need to implement the function pick index, which randomly picks an index in the range of 0 to w length minus 1. Okay, and returns it. The probability of picking an index I is wi by sum of w. Okay, and for example, if w is equal to 1 3, the probability of picking 0 is 1 by 1 plus 3, which is 0.25, and the probability of picking index 1 is 3 plus 1 by 3, which is 0.75. Okay. The problem is, okay. So basically, I understood the question that we have been given an array, and then we just need to implement this function pick index. But what kind of output we are looking into it, like, because then I could, like, my function would basically pick anything right out of these
Yeah.
two arrays.
So let's assume that so you get back an index, right? But let's assume we're going to be running this pick index a bunch of times. So you can't just like return a number. So you have to make a function that, assuming I call this like a million or a billion times, the probability of each of these numbers, like if I go and look like what's the expected probability, how often did I do it? Uh it should be pretty close, right? With like law of large numbers, like if I call this thing, billion trillion times, they should be pretty lined up to what I need it to be. So does that kind of make sense?
Okay, so basically you are saying that suppose if 3 has a probability of 75%
Hmm.
and 1 has a probability of 25%. So
Hmm.
if I call, let's say, 100 times, then 75 times I should see 3 as the output, and 25 times I should see 1
Yeah,
as the output.
obviously not exactly, but roughly. As you go towards bigger
Yes.
numbers, it
Okay.
should be very close to, yeah, exactly. And that's how you could even, I mean, obviously you don't have to write tests for it, but let's say the tests were like, I call this function a billion times, I check how many times did I get something, and then I have some like margin of error for what it needs to be.
Okay. Okay, I'll just think through what approach I can take here.
Hmm.
So we have been given an array, and do we know what would be the expected size of the array? Like, what could be the length of the array that is given to
I don't
us?
think we have to worry about it. I think it can be anything, anything reasonable,
Okay,
like 1 to whatever, a million items. Like, yeah.
okay,
We'll just say like it'll at least have two.
okay. Hmm. So also, will the array be in sorted order, or it can be in any order?
It can be in any order.
It can be in any order. Okay, okay. So, like, what I can see from here is that the higher the number would be, the larger the probability of that number appearing in the pick index function would be more. Basically, if a number has higher value, its probability would be higher if we are calling pick index multiple number of times.
That's right.
So,
Yeah. So basically, the probability of a number is just that number over the total. So the
total.
higher it is, the higher probability it will be. Yeah.
Okay. I'm just thinking on how I can ensure that the probability syncs, like the output syncs in with the probability that we have. So
Yeah, so
I'm just
we don't need an exact, like we don't need, obviously it's a probabilistic function, so it's never going
yeah,
to be exact, but it needs to be close.
okay. So we don't need exact probability around this, and then uh, these are just my thoughts. Higher the number, the larger it would appear as part of the output.
Hmm.
So even if I sort the array, then I would, if I sort the array, then I would know that the number that is at the end of the array, they would be appearing more number of times. But how do I ensure that? I kind of stick to this basic requirement. This is like our core requirement.
Yeah.
So
And then
how
also
do
assume we can have some kind of setup, right? So you can take the array, you'll have some kind of like init function, you can have some setup. And the function we really want to optimize is the pick index. So like the setup might take a while, maybe if you need some kind of like thing that takes a while, that's totally fine, but we need our pick index to be as fast as possible.
okay,
And then basically like I'm going to set up the array once and then I'm just going to call pick index like a million times or whatever.
okay, hmm. Okay. So we need some way to track. Suppose I'm just maybe taking some example, and I'm not able to come up with an approach, so I'm trying to dry run on some example here. So I've taken W as 132, where sum would be equal to 6, and say I sort this array. Suppose if I sort the array, then we would have W equal to as 1 2 3, and sum is still 6. So the probability we will have for W is 1 by 6, this will be 2 by 6, and this will be 3 by 6, which is equal to 1 by 6 is how much? 0.16. Then 2 by 6 will be, sorry, this is 0.16. 2 by 6 will be 0.33, and 3 by 6 will be 0.5.
Mhm.
So I kind of know this is 0.33, 0.5. So suppose if someone calls the pick index function, right? So my function, suppose if this is called, say, this is called three times, then three times ideally my output should look like two times I should be getting at least three and three, and then one time maybe I can get two, or I can get two or three as the output. So
Yeah,
I
but if
would,
you call it a few times, like if you only call it one, two, or three times or something, it's gonna be pretty unpredictable, right? Like ideally you get
right.
this, but it's gonna be pretty unpredictable. It's more along the lines of if I the more I call it, the more it should converge to these numbers.
Okay.
So it's a probabilistic function, right? Like if I flip a
Uh,
coin and I get heads or something, if I flip the coin once or twice, it might be unexpected, but if I flip it a billion times, then it will be like close to 50-50. So
okay. So do we know like how many times it would be getting cold?
sure, let's say it gets called a billion times and like we judge like what are the results of how many times we get each index versus what it should be. But I don't think that's super relevant to the problem. Like I think as long as you make a
Yeah.
function that makes sense, it's
Hmm.
fine. I don't think it matters how many times it gets called because we're not judging it on like, oh, you called it three times, it needs to line up with exactly this. It's more just like, is what you're doing probabilistically accurate to what I'm asking?
Sure. Okay. Hmm. So even if I kind of track down the probabilities like this, and I keep on calling say 1 billion times, then I would have to kind of map down like how many times a particular number has appeared, and based on that I would have to give out other number as the answer.
So not
So
necessarily like try to make it in a way where I see what you're saying. You're basically saying like okay, well, I know what these probabilities need to be, so I'm just gonna like look what the results are. So let's pretend you can't view, like, you don't have access to the results. Like, it gets called and it should work like on its own. It shouldn't be based off of previous calls or something. Because that's
Okay.
not how a probabilistic function works. Like,
Mm.
if I flip a
Right.
coin and it was tails, I can't just be like, well, it was tails, so I'll go heads this time. You know?
Sure. Yeah. 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 Makes sense. Okay. So don't keep track, and then we just keep on calling the function.
Yeah, and for example,
Uh,
that heads or tails, right? If I just say
right.
like, okay, I'll pick a random number, 1 to 2 or something. If it's one, I'll return heads. If it's two, I'll return tails. If I run that a billion times, then I'm going to get close to what I expect. So can we do something like that for this?
Mm. Okay. Yeah. If I call this function get pick index, it should. This is the array that is given to us. I'm not sure it will be data in the array index. And the index will be this. So basically, index would, suppose this is the index, it would go from 0 to length of the array, and someone is calling array say 1 billion times. So what I could do was I could iterate over this index. Oh no, I could not even iterate because I'm not sure how many times they
Yeah,
would
you
call it.
you you don't know how much it gets
Yeah,
called. Your solution shouldn't be based on how much it gets called, and
right.
the results are independent. So you can't store old results and then base your new one off of the other one. Like, it should
Right.
be in a bubble. This should be, the same probability as before.
Right, right. So I don't know, and then if I do this is the array index, I can. So maybe I'm not able to come with an approach, but maybe if we just randomly return some number from the array, that might not give us the correct output because uh, it might maybe giving us more number of ones than threes.
Yeah,
So
like if we just do random number in the array, like what if one, like let's say we have a case of one supposed to be like 1% and then 1% and then like 98%. If you do random number, like they'll all be like one third. So instead of returning a random number from the array, how can we slightly adjust that to
hmm,
account the probabilities?
okay, how we can slightly do it from the random numbers. Uh, if I think I'm not able to come up with the approach on how to go about
Okay,
it.
so let me give you a hint, right?
Yeah.
So basically what we're doing is we're saying our, like, the probability of our number is the count of this number over the total. So instead of saying, like, you were like, let's just get a random number, like what if we know we have a total of 6? If I just pick a random number like 1 through 6, can we use that in some way to see like which one should we return? Right? Like in this example here, like there's 1, there's 2, there's 3. So if
Right.
I just say like I rolled a 5, can I use that to figure out like, well, which one should I return out of these 3?
If you wrote a 5, sorry, did not get this part. If you wrote a 5,
Yeah, so let's just say I pick
hmm,
a random number,
right.
1 to total. And then can I
Okay.
use that somehow to see like which one should I return out of here? So like, if I roll a random number 1 through 6, like just math random 1 through 6,
Right.
um, can
6.
I use that result to tell me then which index should I return?
Hmm, okay. Yeah, like we could do if we pick a random number from 1 to total, that is like here the total would be 6, right?
Mm-hmm.
Sum of them. So from 1 to 6, if you are picking a random number, say you pick 4,
Mm-hmm.
and then you want which number to come out of this.
Mm-hmm.
So we could do like the size, like so suppose the size is n, so
Mm-hmm.
we could do modulo of that. So uh, like whatever number you pick was k, we
Hmm.
do modulo n, which is the size of the array. So suppose in our case it is 5 modulo 3,
Hmm.
which is 2. So it would give me 2 as the output.
But if you do it that way, that doesn't really factor in weight, right? If I pick a random
Right,
number and mod it by n, it's still basically getting a random number. So think about it
right,
more this way. Like, so this first number has like one item in it. The second number has two items in it. The third, like, imagine you have like tokens, right? So like the first number
right.
has like one token. The second number has two tokens. Now I have three tokens. So I rolled a four. So is there any way I could use this four to tell me like which bucket am I in without doing the, because if you do the k mod n,
Mm,
you're just picking a random number again. So if I have
right.
like, if the numbers with high probability have more tokens, can I use the number I rolled to figure out like what bucket am I in, and then the bucket with a high probability would get picked more?
Okay. Okay, so you are basically saying since these are kind of a bucket, so since this has more to give out, so
Mm-hmm.
we basically give from this and then reduce it to two, something like this. But yeah, I get the sense now that we give four and then suppose next number is five. We see this is two, this is two, and then we kind of give any of, like we could give either two or we could give three because both are kind of same, so it doesn't matter to us. And then it becomes one. And next time when someone asks, we would give out three. Something like this we could do.
So the problem with that is like, so what I meant more is like, so let's say I roll a four, right? For example,
Right.
what I could do, like one solution is like, I could just say like, where does this line up, right? So like a
Mm.
four, like the first number is one. Four is bigger
Right.
than one, so it's not in this bucket. Now,
Oh,
in order for it to be in the second bucket, it has to be two or three, and then in order for it to be in the third bucket, it's four, five, or six. So because I have
oh,
the four, I know I'm in the third bucket. And if it's like, if I have the example of like 1198, then
mm.
basically one will give us the first, two will give us the
Yeah.
second, and everything else will give us the third, and we're using this probability. Does that make sense?
Yeah, yeah, makes sense.
Okay.
Okay. This looks like kind of a binary search we could apply.
Yeah, yeah,
So,
yeah. Yeah,
yeah.
that's good.
So,
So how would we do that?
yeah. So basically, for us to apply binary search, we could sort the array, right? And
Okay.
then, but like we could since we are not tracking the number of times the function is getting called, so what we would have to do is uh, like in suppose if the number gets called, then we, like in this case we were saying that the number is getting called from 1 to 6, and then we were seeing where it could lie between 1 to 3, or like from 1 to 98. But if we don't keep track of the number of times the function is getting called, so in that case then how we would decide that where the number could lie in this. So I'm thinking that we kind of track the number of times the function is getting called, and what we could do is, suppose if the function is getting called say 1 billion times, then it could exceed the integer range that we have. So I was thinking we could do it modulo the size of the array or some number, right? And
So how does it matter how many times a function gets called? Like if we go to this 1198, basically one will map to index 0,
right,
2 will map to index 1, and everything 3 to 100 will map to index 3, right? Or 2. And I can call this all I
right,
want, and these numbers will map to these locations. So like if I roll a 1, I return 0. If I roll a 2, I get a 1, and then so on. So it doesn't matter how many times we get called. Like we're never shrinking
right,
these because
okay,
they're idempotent essentially, right? Like one result doesn't affect the other. Same thing with the coin. Like if I roll the
okay,
heads, what's the chance of me getting heads this time? Still 50. So it doesn't matter. So basically what I was saying is like we roll a number and then we could figure out what
okay,
bucket we're in and then we should return that. And you
okay,
mentioned we could do this with a binary search. So how can we do a binary search to speed this up? Because like right
okay,
now, basically what we'd have to do is we'd have to be like, okay, so we like add the first number and then the second number and then
right,
so on, and then whatever bucket we're in, then we have to do it. But if there's like a million numbers, we have to do a
mm,
linear scan every time. So how can we
okay.
improve this with a binary search?
Okay, got it. So, what we could do is we could take the sum of the entire array that is given to us,
Hmm.
and then we could range from the sum from one to the entire sum of the array. And suppose for this example, the sum is six. So for first to sixth, like till the function is getting called six times, till that time we would, what we would do is we would keep a track of something like this, that where in between this we should return what value. And after 6, if it is getting cold, we would always return the last number that is there in the array, just to increase its probability. So we could just track the number of, basically we could just track how many times what output we have to give for 1 to the sum of the value of this entire array, and rest of the time we could just return the largest number that we have as part of the array.
So once again, you're taking a solution that, like this example I gave, we can call it one time, we can call it two times, we can call it a billion times. These
Right.
results don't matter on like the previous calls. So we can't track how many times we got these numbers. Like we need a solution that or I guess maybe we just don't do the binary search. Let's just do this. Like, do you think you could do this solution where we basically just like do have these buckets and we just do a linear scan and figure out what number to return? And the number to return shouldn't depend on the previous result. Like previous result, we can't be like, well, we got the second index like 50 times. Now we should return the first one or something. Like it shouldn't matter.
Hmm.
So
Oh,
literally for this example, it would be like, okay, I guess a random number. If it's one, I return zero. If it's two, I return one. If it's anything else, I return two. That would work for this case. And then if I call this function, like a billion times, then my results are going to be roughly 1%, 1%, 98%. So same thing going back to this first example, like basically if I get a one, I would return index zero. Um, if I get a two or a three, I would return index two or one. So this would be 0, 1. And then if I get 4, 5, 6, 4, 5, 6, I will return index 2. And it doesn't matter how many times I call this thing. I'm going to do this every time. Does that make sense?
okay. If you call 23, then you are giving one, and 456 again.
Yeah, so like 2 or 3 will give me this. This will give me this will like that.
Okay. But in this case also we are kind of keeping track, right? That how many times the value in the buckets are.
We are
So,
keeping track of how many like tokens each value has, right? So the first one has like one token, the second one has two tokens, the third one has three tokens, but we're never changing it, right? Like if we roll a 5, we're not like, "Oh, let's just get rid of this now." Like we
mhm,
keep the
right.
tokens the same forever. That's what I was saying.
Okay.
Like it's not like a rate limiter or something, like it's a
Okay.
probabilistic thing that shouldn't depend on previous ones.
Okay. So, but then the problem is, like, if it's not like a rate limited token bucket, then like I would basically see which bucket has the highest token, and maybe just give out the index of that bucket. But if we don't keep it reducing, then in that case, uh, how would my logic go and pick, say, the index from the second
Yeah,
bucket?
yeah, so your logic would literally be like I roll a number, right? 1 through total,
Hmm.
figure out what bucket this is in, and return. And so you can just store total. So it'd be like, you could store like, have you done like prefix sums before?
Yes, yes.
Okay, so you could be like, okay, so the first sum is 1, second sum is 3, then it's 6. Let's say I rolled a 4. Where is that going to be in? Like, it's basically like, what is the smallest number or smallest index that's greater than or equal to what I rolled? So in this case, it's going to be 6, so I return 2. Right? Because
Okay.
basically, in order to get the first bucket, you have to roll a 1. In order to get the second bucket, you have to roll a 2 or 3. And then the third one's 4, 5, 6. And if you do this, the third one is still like it still has a 50% probability, right? 4, 5, 6 gives you the third one. Does that make sense?
Okay. Yes.
Okay. So maybe you could, if that makes sense, maybe you can move on to coding it.
Okay. So yeah, so this is kind of a prefix approach where we are doing prefix sum, and then uh motion like that is there, which is what I rolled. Hmm, 1 second. I'm just thinking out on this one. If I keep like a prefix sum and someone asks me like calls the function say 11th time, then if he's calling the function 11th time and I need to give some number, I would check where it would lie in this prefix sum
Hmm.
array. So in that case as well, we are kind of tracking how many times the function is getting called, right?
No, it doesn't matter. Like if I roll a two, I'm gonna
Hmm.
return this. If I roll a two again, I'm gonna return the same thing. Like if I just get two infinite times, I will always return index one. It doesn't matter how many times this
Okay.
function got called.
So okay, so basically the pick index function would give some random number, right? And then based
Hmm.
on that number, we would see where it would lie in our prefix sum array, and then give out that number as output.
That's right. Yeah.
Okay. Okay, then I think I can head to the implementation.
Sure.
Uh, the, this will be the main function, so I'll just define the input that is given to us. Say
Hmm.
we have been given an array, and we have been given an array, and I think that should be fine. So I'll just declare an array that is given to us. So this array for now is say 136 as our example, and then we would have to call this pick index function. So the pick index function, right? So the pick index basically expects an array, uh, basically expects this array, and we would just return what value it is returning. So I'll define the pick index function here. So the pick index function would return us the index, returns the index of the array, some random index, returns some random index, and this would take an array here as a reference. And now I would wait. This is the pick index function, right? So I could
Yeah, so I
okay,
remember I told you you can initialize something, whatever you need,
yes,
and then you want to
right,
optimize pick index for speed.
right,
So pick index doesn't have to take the array
right, right,
because
right,
you only have one array and you're never changing it.
right, right. Okay. So maybe in the main function itself, I could compute the prefix sum, right?
Hmm.
So since n is equal to the size of the array, so I'm just defining it here, and I could compute the prefix sum array. I'm initially defining everything as 0 for the prefix sum, and I'll say prefix sum of the first element, that is 0, will be equal to array of 0, and then I'll iterate over uh, I'll iterate over this entire array from this to this, I equal to 0 to n, sorry, I equal to 1 to n, and I'll say prefix sum of I will be equal to prefix sum of I minus 1 uh, plus plus array of I. I think I can keep it 0. Prefix sum of I, that is prefix sum of 0 would be equal, no, this is prefix sum of 1 would be equal to 0 plus array of I. So this can go till less than equal to n, and this will be n plus 1. This is our prefix sum, and now suppose if someone calls the function, so we would have to give out some random. Okay, so now when someone calls pick index, right? So I can maybe declare this as global, not global. I'm sorry. I can wait. I think this is not required. One second. The prefix I. Okay, we have prefix sum and then another pick index function which will return some random index. Okay, so I kind of basically there should be a function in pick index which gives me some random number, and I just return a prefix sum. I just return a prefix sum between those. So maybe generate some random number. I would have something like this. Returns. It returns some random number, which which could be something like for like I'll just come to the implementation of this later. So it would return me a random number, uh, some random number. It would return me some random number, and then I would have the prefix some array. So I would have the prefix some array, and I would have to give out some index which is lying in 1 2 3 6. So if suppose the prefix sum array is of length 50 to 60 and I need to give out a number, so I would have to see where would my 4 fit in between 1 3 and 6. So that's kind of me searching a number 4 in this entire array. Since it is sorted, I could then leverage binary search here as well. So maybe I could use lower bound. There's lower bound function in C++, which would give you the value which is less than or equal to that number. Or I could basically use upper bound, which would give me a value which is greater than that number. So suppose if my number is 4, then it would give me 6 as the output, right?
Does
And
it
I
give
could
you
just
the smallest value that's greater than or equal to? That's what upper bound is?
upper bound gives me value greater than,
Okay.
and lower bound gives the value as less than equal to. So if we kind of say give me upper bound of 4, then
Hmm.
it would say that 4 like number, it would give me the number which is greater than uh, basically it would give me the number which is, oh yeah, I think need to go with less
Like if
than
I
equal.
have like this, uh, if I have like 1 2 3 or 1 2 6 7, and I get a
Yes.
4, I want to ideally get like which one should I return here? I guess.
So you should be returning 6 here, right? In that
Yeah.
case.
Yep.
Yeah. So upper bound would give me the number that is uh, like the next greater number than
Hmm.
this. So since 4 is not there, it should give me 6.
Okay. And
And
if I
it
had
would,
this, then it
yeah.
would give me 4.
Yeah, if you no, if you have 4, then it will give you, yeah, if you have 4, it would give you 4. Yes.
Okay. Got it. Cool. Sounds good.
Yeah. So we could use that. So it gives me some random number, and I could say upper bound of basically I would have to specify the array. So I'm saying from starting of the array to this would be the number, some random number would come here, and I would say from array to array end, and this would basically give me some index.
Hmm.
So I would have, it would give me the number, and then I would have to uh, for the index I would have to do something like this. So this is what I would be returning as part of the output. And yeah, so generate random number, and then I could have the array as, I could declare the array as global. Maybe I could do this, and then I can say array is equal to this. Why is it complaining on this? Upload. One second. This upload on this. Pick index should return with this, and yeah, coming to the generate random number. I'm not sure how to generate random numbers in C++.
You can look it up.
Okay, I'll just check it out.
Yeah, I mean, most languages are like math random or something of the.
Right.
You either get a decimal or you can pick a range, so figure out what's available.
Okay. Okay. So it gives me something like this, and I could return R. So it gives me the random number. I take
Mm-hmm.
the random number and I find the upper bound of it.
Mm-hmm.
I found the upper bound of it. This should be actually prefix sum array. Wait, this should be, yeah, this should be prefix sum array because we are trying to kind of search in prefix sum array. And yeah, so prefix sum array I have declared here. So this also I could declare as a global array, right? uh, Maybe I could just declare this, and this could be just initialized as part of the main.
Mm-hmm.
And what I could say is array dot resize, sorry, prefix sum dot resize to n plus 1, and then it initialized to 0. So what I have done is I have declared this as a global array, and based on the array size here I am resizing it to n plus 1 and initializing to 0, computing the prefix sum here. And when someone calls pick index, we kind of return a random number and we find the upper bound of it. So this should take off n time complexity for generating the prefix sum,
Mm-hmm.
and then the pick index function would generate a random number. So this should be of 1, and then upper bound of an array of length n would give, like, take of and log n time complexity. So yeah, to take of and log n, so total time complexity should be, suppose if this
So it'd
function
be
pick
n
in,
log n for peak index, or well, like what?
yeah, n log n for pick index. So someone calls this number say n times,
So
so it
yes.
would,
So what's the complexity per call?
yeah, so then it would, like, if someone calls this function n times,
Mm-hmm.
then the time complexity would go to n square log n, which I think is more.
Are you sure? So what's the time complexity of a binary search?
I think it, no, sorry, yeah, my bad. Time complexity of binary search is log n. So this upper bound also takes log n only,
Mm-hmm.
and since we are just generating random, we are not iterating over an array of length n.
Mm-hmm.
We are just computing binary search here. So this would take time complexity of log n only, and
Mm-hmm.
if this function gets called n times, then it would basically be n log n time complexity,
Okay.
which should be fine for our case.
So let's try to
Hmm.
test this. Like, think of a way how we could test this. Obviously, we can't get exact things, but can you think of a
Right.
way we could like run a test here, like a basic test, and see like are we close to what we want? Maybe with this
Yeah.
like 136.
Okay, so maybe I can generate, call this function say 10 times, and then
Mm-hmm.
we could say,
Sure.
okay, this should be,
Does it let you run it?
no, one second,
Okay.
should be something like this. Yeah, I'll just run it. Still complaining, I think, around this one. Generate random number was not declared in this scope. Wait, why? calling generate random number, expected initializer before int. Not sure what the generate random. One second.
Mhm.
Why is it complaining for this one? Generate random number and then expected semicolon after toggle. Okay, sorry, it was expecting the semicolon here. Yeah, now we can try.
Okay.
Okay, by I think it crashed somewhere.
So we definitely have. I can just save you some time. We definitely have an error on 42. Like you're making a number from 1 to 100,
Right.
and you don't want 100, right? You want like the total. So that's a mistake. You might have some more.
Okay. Yeah, I can maybe. Okay, I can say it's equal to prefix sum dot size, and then I could do modulo of k. So random number we are taking modulo 100 plus
No,
one.
no, no.
So
I mean, like, so the problem was right. You get the total, you get the prefix sum total, and you generate a random number in that range. Here, you just have a hard coded 100. So what
oh,
this should have
okay,
been in the 123, it should have been 6.
okay. So I could compute the total sum here, and then I could
Sure,
just pass in that. So I'll say that
sure.
accumulate is basically what iterate or linear iteration over the prefix sum array,
Mhm.
and then it would give me the total sum. So initial sum is 0, and I would say give me the sum starting from this array to
Mhm.
the end of the array, and the sum starts from 0. So
Can
yeah,
you do this? Because you haven't actually like initialized it. Can you write it here?
write it
Like
where?
you actually declare the values of the prefix sum on 63. So can you do this in the total? Won't it just give you 0 or something? Or am I wrong
Yeah.
about that?
No, no, that is also we can do that as well. So I can say total.
Is 0 and then just modify it later or something?
Yeah,
Okay, sure.
I could just say total sum plus equal to. We could just do array of I. So we just need the sum of
Sure.
all the array. So
You still need the
that,
first element, but yeah. Like you need a cuz you this starts at index 1 and oh wait, did
right,
you
right.
never do that? I thought you wrote somewhere prefix sum of 0 is the first. Oh, you like
But
deleted
I'm
it.
I'm taking prefix sum array of size n plus one.
Oh, I got it.
So
Got it.
yeah,
Okay. Yep, cool.
so I
So then in
can.
that case, do you see a problem with
Yeah,
this
yeah.
loop?
I would have to take plus equal to array of 0 here.
I see. Okay.
Just 0. And then I could just say instead of this total sum, and I could just say return r. So it
Sure.
would go from 1 to the total sum.
Okay. Okay, it looks like you're still getting
Wait.
yeah, I don't know how easy this is to debug. So.
Once maybe if I just I'm just checking out if I just return 1 here, I'll just check how it is coming if I don't use this.
Sure.
Wait. Uh, we have declared an array, prefix sum, total sum, calling pick index 10 times, generates a random number, gives me the upper bound. I written that as output. Okay. Shadow whites.
So it says there's a
Students.
heap buffer overflow here. on 62, right? Um,
Yes.
so I think this is a bug because array I, you're doing 1 to n and n
Oh,
is 3.
okay.
So
Sorry, this should be array of 5 minus 1 then.
yeah,
Yeah. No, sorry, my bad. Wait, why? What? So, still complaining on line 69. 60. One second.
sure. Okay, so did that work? Not sure to be honest.
444. Wait. And just comment this one out. Return R.
Okay, so it is doing some. So it is that
And
block.
comment this one out now. I got this. I think it's prefix sum, resize, and this one. I think I could just resize it to 1 second.
Sure.
I'm just checking if resize has some syntax issue or not. No, it is correct only. Resize to 2. But
Yeah, the array part seems fine. The prefix sum thing seems fine to me. Oh, you have a bug here too. This is off. This is the what's it
oh,
called overflow.
so yeah, now it should work fine.
Okay, so it looks like you're getting 4, and that's it all the time. Is that
Yeah,
correct?
yeah, yeah.
4 shouldn't even be a result. It should be
Yeah,
0
4
to
should not be a result, right? So I am saying perfect sum. Okay, so sum is 136, and I get. Let me see what random number I am getting here. I'm just debugging here.
sure.
So this is the random number that I get. Prefix sum is 1. Okay,
You're
I got
getting
a random number
5,
5.
which is
It gave me
incorrect, and you're
3.
always getting it, which is
Hmm. So let me see
incorrect as
what is
well.
the prefix sum I get.
Okay. Okay,
Total
that
sum I
is
get is
also
9,
incorrect.
10. Yeah, that is also.
Oh wait,
I do
your starting array is 136.
not
It should be
required.
123, I think, right? That's why. Like your input array is 123 and it's 136 here. From the example, it should have been 123.
Okay, no, I can change that as 132.
Sure. Yeah.
Prefix total sum of value 5 minus 1.
Okay, you're still getting
I get the
you're
sum
always
now.
getting the top number.
I get the sum as 6. I get the
Yeah.
random number as 666 always.
Yeah. Okay,
There's
I'd
some.
say let's just stop here
Yeah,
because like the rest of it's just
yeah,
debugging. Then we can
sure.
go for like my suggestions and all that stuff. Okay.
Yes.
So basically, I mean, how do you think you did?
I think I did pretty bad.
Pretty bad. Yeah. Yeah, I
Yeah.
agree. So for example, like for meta, this is like a question out of 2. So
Oh,
you would get like 2 of roughly this level. And
okay.
obviously like you didn't finish the first one
Yeah.
in, whatever it was, like 45 minutes. So there's a couple things I wrote down. So you did ask good clarifying questions. You asked like actually don't remember exactly. I think you asked like how long can the array be, like what can the numbers be, that kind of stuff. I'd say for clarifying questions, ask questions, but only if they are going to change your solution. So
Okay.
you don't want to ask things that are like, for example, how long can the array be? It's like, I mean, if I tell you it's like a million or a billion or a trillion, it doesn't really matter. Like, as long as, yeah, I would just ask, like, can it be empty? What's the smallest? You know, like, as far as the length, like, people aren't really going to give you constraints. It's not like leak code. You know, they're not going to say, like, array length is like from 1 to 1 million or whatever. But
Right.
you should still ask clarifying questions. Like, for example, can the array be empty? Because then you know you already had some bugs that were like out of bounds. But if it was empty, then you'd have even more. So that's what I would say for clarifying questions is like ask things that are relevant for you. So for arrays, can it be empty? For strings, can it be like uppercase, lowercase, empty, whatever, that kind of stuff. So, but I think you asked pretty good questions overall. So like the planning of the solution and like what to do, you really went wrong. I kept telling you like you can't reuse old results, and you kept trying to push towards that like direction over and over.
Mm.
So maybe it's just like one of these problems where it's like if you don't know, you don't know. But I feel like it's definitely one where if you do enough problems, you can figure it out, right? You can basically figure out like, okay, well, I need to have probabilities. I need to have some kind of probabilistic thing. If I give every number, if I give every number a weight, then how can I like randomly get one? And you should be familiar with like math random and that type of stuff, obviously. Like I'm assuming you are like random numbers and like that kind of stuff, because it's like reasonably common. Is that correct or no?
Right.
Okay. So yeah, so that's the big thing is like so basically time wise, like if this was like a 20-minute problem, you ask questions in a minute or two, you need to come up with a plan on how to solve the problem in around 5 minutes, I'd say. And you were really stuck, and I gave you a lot of hints, and
Mm.
eventually I did kind of basically tell you what to do. Um, so that would have been like a fail right there. Like maybe if I give you a small hint and then you're good, but I had to give like a lot. So
Yeah.
and obviously some problems are kind of hit or miss. Like this one isn't really like can you do a breadth first search or whatever, right? So there are going to be problems where like you just don't
Mm.
get it and it's kind of bad luck. But I do feel like this one, if you just do enough problems, like it's definitely not like once you've seen the solution, do you think like if you do enough problems, you can definitely come up with this? It's not some crazy like trick question.
Okay.
Yeah, so I'd say that, and then yeah, and then the other thing is even when I gave you the solution, like even if I gave you like here's kind of what we need to be doing, you were a
Right.
bit sloppy in the coding. I feel like you had some global variables. I mean that's personal preference, I guess. But you definitely should be familiar with like your language. Like if you have to look up random, sure. But if you get like a billion off by one errors and a billion like out of bounds errors and like you're using the wrong array here and the wrong array there, like that's not great. So I
Right.
would definitely say basically work on code quality and like knowing your language like pretty well, and being able to do these things quickly. So how many leak codes have you done, I guess?
I have done, I think, around 700 something.
700. Okay, that's a
Yeah.
lot. And do you
Yeah.
do you do on average like what, yeah, like mediums or something?
Like I have, 1 second, I can just.
Okay.
I have around 494 mediums and 245 easy and 63 hards.
Okay, so that's not bad. So like number wise, you should be at the level where you can pass, like a big tech interview. Um,
Okay.
so it just comes down to like being able to do these things quicker and like being able to do them better. And like I mean you were familiar with all the topics, which is good, right? Like if you've done that many, you've heard of prefix sums, you heard of binary search,
Mm.
like all
Right.
that stuff. So the main thing is just like try to come up with the solutions quicker and try to code cleaner. And yeah, definitely like I think we stopped at like 7:50, we started at like 7:05, so I think this was around 45 minutes, and you basically
Oh.
didn't really even finish the first problem in that time. So definitely would work on that. Like just like when you do the problems, do you like time yourself, or like how do you practice, I guess?
I usually like, suppose if it is a medium problem, I
Mm-hmm.
usually try to time box to 15 to 20 minutes.
Mm-hmm.
And then if I'm not able to do it, I try to refer to hints. And
Mm-hmm.
even if that doesn't click, then I go for the solution.
Yeah, I think that's good. I think yeah, time yourself, and then if you can't figure out, like if you get stuck, just start reading, like hints and stuff quickly, and then yeah, basically do more problems. So this could have been like, it's hard to say. This could have been just like it was a weird problem, and this was like a bad problem for you, which is maybe why I could have just said like 20 minutes in, I could have just said like let's just move on and see if you can like recover in the next one. Maybe I should have done that instead of just like kept going. So maybe if
Mhm.
you want to like schedule another one or something, we can do some more problems and see like was this just like a bad problem, or where are you actually like struggling a lot. It's hard to say without like doing a
Yeah,
lot.
yeah, yeah.
But from
I
from
can.
like my even if this was like a two problem text screen from doing this badly, I would say in the first one this would be like a fail. It's pretty hard to recover from like
Hmm.
not knowing. If you're kind of close and I need to give you a little bit of hint, then like sure, but I needed to give you like a lot. um
Right. So,
so
so
oh yeah, go ahead.
the, like the evaluation criteria would be like, can you just give out the evaluation criteria? Like, how would, like, can suppose if, for example, candidate is not able to uh, fully write down a working solution, and suppose if he is able to come with the intuition, he is able to come with the approach, then like what are the steps on which you get judged or uh, evaluated on, like in a problem solving round?
Right. So first of all, I would say the clarifying like let's just go with like the first part. Right? So the
Right.
clarifying questions. If you didn't clarify something that is critical to the problem and you never figured it out, right? Like for example, the array could be empty and your code just crashes. That's not good. So as long as you clarify like the really obvious stuff, that's like a pass, I'd say. Right? Does that part
Okay.
make sense? And then the plan is like, if I like, are you able to come up with a solution that make sense if I either give you a small hint or no hint. So, if it was like out of five, five is like you come up with like a good solution quickly. I gave you no hints, without the coding. Like it just makes sense. A four would be like I gave you like a small hint here and there. A three would be
Okay.
like maybe I gave you multiple hints, and then everything else is like I had to give you a big hint or like basically tell you what to do. So I'd say like if you get anywhere, between like if I had to basically tell you what to do or give you a big hint, like in this market, I'd say it's just a fail, right?
Okay.
Like if I like, and I'd say in this case, this would be like close to like if it was out of five, it would be like a one or two out of five because I had to give you a lot of hints and you were still
Right.
kind of going in the wrong direction. So from there,
Okay.
let's say you planned it all out correctly. Then the code is like, did you get a work? So obviously, like if you can't run your code, if it's a company that you can't run your code, it's going to be a lot more forgiving, right? Like if you have some small syntax errors, like it doesn't really matter. But if you have a lot of like off by one errors, or if you're literally using the wrong variables and you can't figure that out, that's going to be not good either. So for one of the examples, I think you used like the normal array instead of the prefix sum array or something for one of these, and that's also not great. But as long as you can basically come up with like a working solution or close,
Okay.
with a few bugs, like bugs that don't really matter, missing semicolon stuff like that. But if you have like actual critical bugs in your code, like your logic is wrong, like your variables you're using are all completely wrong, then that would be a fail. So I would say because you weren't able to come up with, obviously there's the time part, you weren't able to come up with a working solution, then that's also going to be like a fail. And then as far as like a working solution versus like optimal, I would say, and from what people I talk to say, nowadays you pretty much, especially for problems like this, you pretty much have to come up with optimal. So like if you come up with like a linear search instead of binary search, maybe if it's like if you come up with linear search and there's like I don't have to give you any hints and like your code is good and it's like a text screen, maybe you pass. But if it's like an on-site, then it would be like, maybe like lean no higher or something. Or maybe you do come up with like a linear solution and I'm like, can we improve this? And you just can't think of any way, then that would be like a lean no higher. So I do think the bar nowadays, especially for like,
Okay.
the companies that ask you like pretty generically code stuff, is like you have to be like very close to perfect to pass.
Okay.
Um,
Okay.
so, so yeah. So hopefully that makes sense. I think I pointed out like the questions, the coding, and then the other part is yeah, like code quality. How familiar are you with your language? And I would say, obviously I don't use C++, but I know in general languages, like you don't really want to have global variables. So ideally, I would have made like a function or like a class, and then that class had like some class variables, kind of what you were coming up with in the beginning, and then you would like make an instance of that class, and then you would just call like pick index. Obviously, I think as far as like your like who interviews you, If you say your main language is C++, you're probably going to get interviewed by someone who knows C++ really well. So then they can like find the bugs and see what you're doing wrong. Like I can read it somewhat, but I'm not like an expert in it.
Right.
So that would be the other thing. So, and that's another important thing to work on is like code quality, readability, not having overcomplicated solutions. If you have a solution that's working but it's really weird and really hard to understand, uh, it might be like a pass, but it's still like not optimal because at the end of the day, you're like a software engineer. You want to make like simple solutions that are like readable. Um, so that would be another one. But I think here it's like I don't know the exact like these are the exact criteria like that I would grade on but I know like basically the way you performed in this one like no matter how you got graded it would be a
Right.
fail, right? So it doesn't really
Right.
matter.
Right.
Um, so that's the things I'd work on, and hopefully that makes sense. And then yeah, the big thing is like for this kind of level problems, you basically want to try to get it done in like 20 minutes. And you can look this up. I think this is called like leak code pick index with weight or something. You can look it up after this. Yeah.
Sure.
Uh,
Okay.
yeah. So hopefully this was like helpful for you. And also, so because I haven't done a lot of these with like, I've only had a couple people that like signed up so far. I'm curious, like, what's your feedback as like things I can improve, things I did well, and things like that. And I can actually stop the recording here and just do that.
Yeah.